All right, we're going to start doing some radical equations and problem solving. So still in chapter 7, just moving on. The main thing with this is to make sure that you check for extraneous solutions. Extraneous because sometimes we algebraically can find a solution, but when we plug it back into the equation, it does not work. And the reason why we have to check for that for radical equations is because when you square both sides of an equation, what could happen is inside of this radical could have a negative number. But we cannot square root a negative and get a positive over here. So that's why we have to double check our answer. So that's the main thing though, is to solve a radical equation, get the radical by itself, then square both sides. That way the radical will cancel out with the square. So we're left with 3x minus 5 on the left side is equal to 49. And then pretty straightforward from there. You add 5 over. So I add 5 to that. You get 54. And then divide both sides by 3. And you get, let's see, 60 divided by 3 would be 20. So this must be 18. You can double check with the calculator. Now, I know I said that we cannot square root a negative, but x could have been a negative in a different context. But this problem, x could not have been a negative. So if I plug 18 back into the problem, 3 times 18 must be 54, minus 5 is 49, and the square root of 49 is 7. So I'm just checking my work. A little check mark there to say, hey, I'm good. So just be ready for that. Okay. So you might have also heard me say the phrase isolate the radical, get the radical by itself, because that is not the case on this second exercise. So what you need to do is notice where the radical ends and get the equation to stop right there. So I'm going to add 4x to the right side, and 0 plus 4x is still 4x. So from there, I can square both sides. Just make sure that you square each piece. Okay, what do I mean by that? Is we have 16x minus 3 is equal to 16, because 4 squared is 16, x squared. And then from here, this is why we do this unit after the factoring. I'm going to subtract 16x to the right side and add 3. And then as I'm looking at that, let's see, is this factorable? Let's see, 16 times 3 is 48. Factors of 48, maybe 12 and 4. There we go. So maybe you'd rewrite the problem as 16x squared. It'd have to be minus 12x and minus 4x to get to that. And then you can group. So I believe that's 4x. What do we have? 4x minus 3. And then factor out a 1. So that's 4x minus 3. This is taking me a while. Hopefully you're following along. If not, feel free to write down any questions you might have. 4x minus 3 and 4x minus 1. Remember, the parentheses are the same, go together, and then your leftovers. So we can deduce then that your answer would be 3/4 by using the zero product property and 1/4. But you have to check your answers. What do I mean by that? Is if you were to plug in 3/4 into the problem up here, let's see, well 16 times 3/4, well 16 divided by 4 is 4 times 3 is 12, minus 3 is 9, square root of 9 is 3, minus 4 times 3/4 would be 3, and 3 minus 3 is 0, so that worked. I'm doing this in my head, by the way. And plug in 1/4, well 1/4 of 16 is 4, minus 3 is 1, the square root of 1 is 1, 4 times 1/4 is 1, 1 minus 1 is 0, so both of these answers work. Okay. I know I warned you about extraneous, and it seems like everything seems to be working right now. So let's move on to the next one. Now this one, you don't have to worry as much about extraneous because you can cube root positives and negatives. Okay, but I did need to bring that to your attention. So subtract 1 over to isolate the radical. So we're looking at 2. This time to undo the cube root is to cube both sides. So x minus 2, because those two pieces cancel, must equal 8. And then add 2 over to get x equals 10. So as I look at this, 10 minus 2 is 8. The cube root of 8 is 2, plus 1 is 3. So this answer does work. Hopefully I'm not going too fast, but if I am, you can always pause the video and go back to this. Here's exercise 4 and 5 out of the textbook. So notice the radical is by itself. So as I square both sides, notice that I'm putting this in parentheses because what I get on the left side is the radical goes away. And on the right side, you really have to FOIL this because remember, x minus 2 squared really means, maybe I should cross this off and rewrite it as x minus 2, x minus 2. And then you can see that it's x squared, negative 2x is negative 4x, and negative 2 times negative 2 is positive 4. So as I go through this process, let me switch back to that other color. Like I said, this side equal to 0, so I have x squared. I'm going to add x to the right side. So adding x to the right side would give me negative 3x. And subtract 4 to the right side would give me 0. So I don't have to write anything. I guess if you wanted to, you could write plus 0, but a waste of time. You can factor this. Just as a reminder, it's the greatest common factor, x and x minus 3. So my two answers, when I'm finally getting to an extraneous, are x equals 0 and x equals positive 3. But let's start with 0. If I plug 0 in for both of these x's, this one and this one, 4 minus 0 is 4. The square root of 4 is 2. But on the right side, 0 minus 2 is negative 2. That is not a true statement. So x equals 0 is extraneous. X equals 0 is extraneous. It does not actually give me a correct answer. And I could explain it graphically why that doesn't work, but let me go ahead and explain that. 3 is correct, because 4 minus 3 is 1, the square root of 1 is 1, 3 minus 2 is 1, so x equals 3 is the only correct answer. So graphically, check graphically. And I'm not going to go to a graphing calculator, but if I were to plug in the square root of 4 minus x, what we have is a function that is shifted to the right 4 units. And you can check with a graph why it's shifted to the right, because it's also got a reflection going on this way. And then the graph of x minus 2 goes down 2, and it's going up 1, right 1, up 1, right 1, up 1. And you can see graphically that that graph intersected at x equals 3, and if I want to be specific about it, they cross each other at the y value of 1. And notice that x equals 0 did not cross. The two curves did not cross each other. So if you have a graphing calculator and you want to check that out or go to Desmos, you can verify that everything I said here was true. That you can check your answer graphically, and we care about the x value where they intersect each other. So there you go. Now exercise 5 is a little bit trickier. The reason why I warn you about that is because you notice that there's 2 radicals. Now if I were doing this problem, I would want to split up the radicals. I'm not saying that my way is perfect, but my way would work. So just subtract that root 3x to the right side. And then from here, we can square both sides just like I did previously. So I have 8x plus 1, because the square root and the square cancel out. But you do have to FOIL this. So we're looking at 4. What do we get? Minus It would be 2 root 3x minus 2 root 3x. So it would be 2 root 3x. And then a negative root 3x times a negative root 3x is a positive, well, the radical would cancel out. So then from here, what do we get? Well, let's set it equal to 0, kind of like what we did before. Actually, I want the 0 on the other side. I don't know why. Just kind of feeling that way. 8x minus 3x would be 5x. And then I'm going to add that 4 root 3x to the left side. And then I'm going to subtract this over. I feel like at this point it's probably be best to, because nothing's canceling out the way I'm seeing this. Unless what we're supposed to do, I think what we're supposed to do, now that I'm looking at it, is isolate that radical again. Okay, so that wasn't terrible. But I think what the book wanted us to do is to leave that negative 4 root 3x on the one side, so then we can square everything again. I would argue that this is an ugly problem. But anyway, let's keep going through. 25x squared, it would be negative, what do we get? 5 times 3 is 15. 15 would be negative 30. X plus 9 equals, that would be 16 times 3. Because 4 squared times 3 is 48. X. Oh my goodness, this is an ugly problem. 25x squared minus 48, 58, 68, 78. X plus 9. Ugh. I'm already tired. Imagine how you guys feel. 25 times 9 is 225. If I'm looking for factors of 225, that would add to be 78. I don't even know. I'm about to just go to a graphing calculator and show you how to do this graphically. Let's just do that. I'm going to pull up Desmos. Alright, so all I did is I just typed in the original equations as y equals. And you can see after, maybe I can zoom in. You can see the point of intersection of the function is at x equals 0.12, which I feel like I was leading you down a path that was not going to be very, very helpful. So I think what I was going to do is get you 2 answers because I had a quadratic, and clearly one of those answers must have been extraneous. So the only answer we want is x equals 0.12. X equals 0.12. I feel like maybe this was 75 and 3. And then you could have factored it, make them both negative. And one of these would have been extraneous, and you can check graphically that that is the correct answer. 25. I believe it's 3/25. I believe 3 over 25 would give you that correct answer. 3 divided by 25. Yeah, 0.12. Okay. So I was really close to getting to that answer, and I just gave up on myself. And eventually, I do want you to know that you can solve these problems by using a graph as well. I'm sort of at my time limit, so I'll save these word problems for the second video. And then that'll be your assignment. So just come back and check out how to do exercise 6 and 7.